right. All right. What do we got going? I'm hearing an echo. I don't know if you are or not. Sometimes I can't do much about that.
I'm not hearing one.
Okay, good. As long as it's not disturbing you, I can live with it. You gonna read problems to me?
Yeah. I mean, most of it again is just factoring.
Okay. Let's just go through it. You got a test tomorrow, right?
Yeah.
Is your whole test going to be on factoring?
Yep.
Okay. Let me bring up something that I just was looking at with another student and see if this would be helpful to you. This may not be what you're doing, but it might be. If you have plenty of problems, we're good to go, but I got lots of factoring problems here if we need them. These tend to be a little different.
Those look pretty similar.
Okay, this is from Honors Algebra 2.
Oh, the only thing that we don't have is we're only doing single variable.
So you're not doing sum of square or difference of cubes or sum of cubes?
Nope.
All right, let's not use this one then. Let's go ahead and have you read them until you run out, and then maybe I can find something.
Okay, the first one, it's a word problem, so those are just kind of weird.
Okay, let's do it.
And it says the story behind it's a man throws a ball off the top of a building.
Okay.
The table shows the height of the ball at different times.
Okay.
And the table it's showing is the time and the height. And for time you have 0 seconds, 1 second, 2 second, and 3 second.
What's the various heights?
1, 2, 3. 46, 63, 48, and 1. And it just says, for the first part, find the quadratic model for the data.
Okay. So here is the building the guy's standing on, and he's throwing a ball like that, right?
Yeah.
Okay. So this building must be 46 feet high, because at time 0 seconds, the height is 46. And then it goes up at 1 second. Time is the horizontal axis. Height is the vertical axis. So this point here is 63.
Okay.
At 2 seconds, it's right there, which is 48. And at 3 seconds, it's 1. So there's the graphical representation of that. Now, to put that into a quadratic form is going to be the height is equal to minus 16 t squared plus some constant times t, which would represent his vertical velocity, plus a different constant represents the starting spot, which we know to be 48. So, were you given that equation at all with the minus 16 t squared? You weren't given that? So,
no, we're supposed to pull it out.
You're supposed to figure it out from scratch?
Yeah.
Okay. That's fine. Let's put A in front of that, B in front of this. So there's our general equation of a quadratic. And we're going to try to fit this. Okay. Well, we have enough points that we should be able to figure out this equation. When t is 0, the height is 40 feet. So, in fact, let's call height f of x, f of h. No, we'll call it f of t because it's the function of t. But this is going to represent the height. Let's call it h of t. Okay? So we know that h of 0 equals what?
46.
Right? So h of 0 is when we plug 0 in for t, therefore c must be equal to 46. So now we've narrowed the thing down to this. Okay? Now, when t is 1, what is h of 1 equal to?
63.
And what is it equal to when I plug in 1 for t?
Would be a times 63 squared.
No, remember you're plugging in 1 for t.
Oh, this would be a times 1 squared plus b times 1.
So there is one equation, right? Let me erase this picture because I want more room to write in. So there's one equation. Can't solve for a and b yet because we just have one equation and two variables. But we've got more data. So let's figure out what h of 2 is. First of all, it's 48. What is it equal to in terms of a, b, and a number? Plug in 2 for t.
Be a times 4.
So that 4a plus
2b
2b plus 46.
Yeah.
There's our second equation. If you have two equations and two unknowns, you can solve for a and b. Should we go through doing it?
Yeah.
Okay. I'm going to rewrite this first equation as a plus b equals 17. See how I did that?
No.
Just subtracted 46 from both sides.
Okay.
Okay. Second equation. 4a plus 2b equals 2 by subtracting 46 from both sides.
Okay.
Now with two equations and two unknowns, I can solve these. What's the best technique to solve these? Elimination or substitution?
Elimination?
Yep. What am I going to do in order to eliminate one of these variables?
I don't know.
Well, let's just multiply the top by 2.
Okay.
Now you're allowed to add or subtract equations. So if I subtract these two equations, I'll get rid of b. I'll have minus 2a equals 32. So a equals minus 16. Oh, how did I know that? It's because that's the most standard equation in physics.
Okay.
The equation of motion So it's always, as long as you're dealing in feet per second, this is always minus 16.
Okay.
What's B?
You
Go back
take A
and choose.
plug it
Yeah,
in.
let's choose our simplest equation. Let's go back and take this. If A is minus 16, B must be
A plus B equals 17.
33.
30.
Because we have
Yeah.
minus 17 plus 33. Ooh, I did it wrong. 34. 34. Here, I was doing that math in my head, and I messed up. So there's our equation.
No, it's 33. A
Oh,
equals
because A was
negative 16, not
negative
17.
16, not 17. Okay. Boy, that's unusual. It's not often you make two mistakes and end up with the right answer, because one cancels the other. All right, I think that's the easiest way to do that.
Okay.
And they didn't even need to give us this third point. In other words, we only needed 3 points to come up with the 3 variables, A, B, and C.
Okay.
Now, were there other questions with that? In other words, okay, so after you come up with the equation, what else do they want to know?
The second part says use the model to estimate the height of the ball at 2.5 seconds.
Okay, well, that's the same thing as saying, what is h of 2.5? So help me write this. How do I do h of 2? If h of t is equal to this, how do I do h of 2.5?
Once you substitute 2.5 in for all the t's.
Yep. So what do we got here? We got 25 over 4 plus 165 over 2 plus 46. Now, where that echo is annoying on my end. Let's see, I'll just reduce that to 82.5 plus 46. So what do we have? We have 54. I'm going to subtract from that 28.5 positive. So that is the height of the ball at 2.5 seconds.
Is 28.5?
Uh-huh.
Okay.
Unless I did my math wrong. Let's see, that becomes minus 4. I think that's right.
Yeah, that's what I got.
Okay.
I did it with decimals. I just think they're easier.
Yeah, they probably are. Plus, if you're using a calculator, they're definitely going to be easier. You're squaring stuff.
Yeah.
Okay, what else do we want to know? They must want to know where does the ball hit its maximum height and what is it?
63 feet.
Okay.
Which would be at 1,63. Wouldn't that be your vertex?
Right. The vertex is where it hits its maximum height, for sure. So let me make sure you did it right. The x-coordinate of the vertex is minus b over 2a. Right? Is this how you did it?
It's not how I did it then, but yeah, I know I'm doing that.
Okay, so that's the x-coordinate. It's not 1. So to the y-coordinate, would be this number plugged into this equation, whatever it comes out to be. So the y-coordinate is going to equal h of minus 33 over 32. Whoops, it's minus b over 2a, so this should be negative also. So it's a positive, but it's still 33 over 32. So I don't know if you want to go through that math or not, but the time that the maximum height occurs is going to be 1 and 1/32 seconds.
Okay.
The height that the ball will be at will be h of 33 over 32.
Okay.
What else does it want to know about this problem? Probably wants to know, when does the ball hit the ground?
No, that was it.
Really? Okay.
Yep.
If we wanted to know where the ball hit the ground, that's when h of t equals 0. So I would just set that equal to 0 and solve that quadratic. And that's going to give you two spots where the ball hits the ground. One of them will be negative, which you'll throw out. The other will be positive, which will be the time where it hits the ground.
Okay.
Okay? Got any other word problems? Or problems you want to go over?
No. The other one's the same.
Okay. All those motion problems where balls are being thrown up, whenever you throw a ball up, it always follows a parabolic path, like that. And the equation is always minus 16t squared plus some number times t plus some number. This number is actually the velocity that the ball is thrown at. And this number is the height that it starts at. So I don't know if that's helpful or not, but whenever you have parabolic motion problems, it's always that.
Okay.
They'll usually kind of give you this equation, that part of it there. But in your case, they do.
How come it's always negative 16?
Because that's the constant due to the acceleration of gravity.
Okay.
In other words, when you throw a ball up, you're throwing it at a certain velocity, but at every point you got gravity acting, pulling it down. And that constant of gravity is that. Gravity's 32 feet per second, and we're going to divide it by 2. Wow, we get to 16. But you didn't really need to know that on that last problem, because you could calculate what that coefficient was.
I think that's all of them that I've found in the book.
Okay, you want me to try to find some just standard quadratics for you to factor?
Yeah, that'd be great.
Is that helpful? Yeah, these are equations in standard form. Let me give you some of these. Let me give you an easy one. In fact, I might have given this to you last night. Did I? You recognize this? Tell me. I've had
I think you did.
four Algebra 2 students since last night, so let me give you a different one. Okay, to solve this equation requires us to factor this, or else use the quadratic formula. But trying to factor, it's probably easier than using the quadratic formula off the get-go. We only use the quadratic formula if we can't factor.
Okay.
So what goes here and here?
5x and x.
Okay. Now what's the next step in this process?
It's
Look at the sign on the constant term. That's the next step. The fact that it's positive means what about these signs here?
they both have to be the same.
And the fact that the middle term is negative means they both have to be what?
Negative.
Right. In other words, you're correct. They're either plus plus or minus minus. Look to the sign on the middle term to tell which.
Okay.
Okay? Now, because this coefficient is different than this coefficient, this becomes a much harder problem. I can no longer say that I'm looking for factors of 6 that add to 13. Doesn't work that way. I'm looking for factors of 6, but I'm going to have to use some trial and error. So, what are factors of 6?
2 and 3.
And 6 and 1. Those are the only sets of factors. So I always suggest students try the ones that are closest together. So I would do a 2 and a 3. It's my first step. How many, what would that give us in the middle if I do that? In other words, to figure out the middle term, that would give us minus 2x, minus 15x. That would be minus 17x, so that isn't right. So let's switch them around. Let's try 3 there and 2 there. Does that work?
Negative 3x and negative 10x. Yeah, then you get negative 13x, and that's your middle term.
That's the answer. Okay, let me see if I can find some others that are like that, because those tend to be a little harder. Again, if you recognize any of these that we've done already, holler. I got a whole page full. I would suggest taking these one step at a time rather than trying to derive the answer in your head all at once. In other words, let's start with what goes there and there.
8x and x.
Okay, is that what you would try normally?
Yeah.
I would try the two closest numbers. I don't know what the answer is. That's what my starting spot's going to be. Because 4 and 2 are closer together than 8 and 1.
Okay.
Okay. Now, when I examine that, I know the signs have to be opposite. But in this case, because the coefficients are different, I have to allow that they might be like this also. Now, factors of 5. What are factors of 5?
5 and 1.
I'm just going to start trying them. In other words, at this point, for me, it's trial and error. Does this work?
The 10 and if you did 4x plus 5 and 2x minus 1, it works.
No, that's what I've got here. But notice that gives us 10x there, minus 4x there. So it almost works. So the fact that it's the right number, wrong sign means what? What do we have to do?
Flip them?
Put the 5 with the negative sign? Yeah, flip the signs, not the numbers, flip the signs. So this becomes minus, that becomes plus, and that's going to work because that's minus 10x, that's plus 4x, that gives you that.
Negative 6.
Okay? Find another one. Goes here and here.
3m, both of them.
Yeah, that's a good place to start. That's not necessarily correct, but it might be 9 and m, but I can tell by looking at it. So what are my signs?
They're both going to be negative, or minus signs.
Factors of 25?
5 and 5.
That works. Here's a little different one. Tell me if any of these you're not, if you haven't seen anything that looks like these. Tell me.
Okay.
Now, before you try to factor, a couple things going on with this problem. First of all, I'd rather this number be positive, right?
Yeah.
Harder to factor if you have a negative sign in front of your square term. So I could definitely divide everything by minus 1 to turn this positive. Notice that when I divide the right side by minus 1, I still have 0. But there's actually something else I could divide everything by. Makes it simpler still.
Negative 3?
Right. So b squared minus b minus 30 equals 0. So this is the same problem, much easier to factor. Notice now I always have the same coefficient in front of the b terms. What's next?
I
can't. Oh no, I can't.
Opposite.
Right. They have to be opposites, plus minus. And notice that I don't have to write minus plus because these coefficients are the same. So plus minus is going to be the same as minus plus. No way it can be different.
Okay.
So what's the last step here? We want factors of 30 that subtract to the number 1.
6 and 5.
Okay. Which side does the 6 go on?
Plus 6 minus 5.
No. Always put your biggest factor with the sign of the middle term. Sign of the middle term is negative, so I'm going to put the 6 there, the 5 there. Notice that that causes the negative to be extra weighted and gives us the negative as the middle term. So that gives us 5b minus 6b, and we get our minus b as the middle term.
Oh, okay. Yeah, I thought we were going for just normal 1, not minus 1.
Oh, right. Okay. Yeah. Okay. So had they said, if they'd have just said factor this expression and not put it in an equation, then I would still need to carry forth this minus 3 like that. And the final answer would be this. But in my book, this came as an equation like this. So I factored out minus 3, divided both sides by minus 3, and you get this. And then you can solve it, and you don't have to carry your minus 3 for it. And the solution, the zeros for this function, would be minus 5 and plus 6. In other words, b equals minus 5, or b equals 6 will be a solution to that equation.
Okay.
Okay. Now, is most of the factoring you've been doing, is it of equations set equal to 0, or is it just quadratic expressions?
Both.
Okay. Let me find some quadratic expressions. Factor that.
Okay.
This is something you want to be able to recognize. You're going to be seeing it for 3 years. And that is, it's called the difference of perfect squares.
Yeah, wouldn't it be 4x minus 3, 4x plus 3?
Good? In other words, take the square root of that part, you get this. You take the square root of that number, you get this. But a squared minus b squared is always equal to a minus b times a plus b. That's the difference of perfect squares.
Okay.
And the one that's usually the hardest, the most often overlooked, factor that.
X squared minus 1 would be x plus 1, x minus 1?
Yeah. Most people don't tend to think of 1 as a perfect square, but it is. So we have difference of perfect squares there. Okay. Let me look in my book. More. That's A. Whenever you see just 2 terms like this, there's no A term, always think difference of squares. It almost always is.
Okay.
It's the square root of that.
7.
It's the square root of this.
10. A.
Here's your answer. always start with the term on the left, square root of that, minus the term on the right. About this one. Tell me if I'm getting off the beaten path here. In other words, if you're not seeing any of these kind of problems in class, let's not do these. Okay?
No, we see them.
All right. Looks like it would be the difference of perfect squares, but that's not a perfect square, and that isn't a perfect square.
No.
But is there a greatest common factor?
2.
Now what is this?
Then you can keep going, and then it's perfect square.
It's already a perfect square. In other words, 9x squared minus 1 is 3x minus 1 times 3x plus 1. In other words, I took the square root of that, which is 3x.
Yeah.
Okay. So even when they don't look like perfect squares, you're usually going to be able to factor a number out so that they will be perfect squares.
Okay.
I hate using the variable t.
Always looks like an addition sign in the message.
It does. I just finished a session with a student, and one of the problems had the variable t, and he wrote it, but he didn't put a plus sign in front of it, which it needed. Because it was being added. He saw the t as a plus sign. So, all right. So what can I do here?
Difference of perfect squares? No, it's not.
Not quite, because that's not a perfect square, nor is that. So maybe if we factor out a greatest common factor first.
6t.
What's left?
T minus 6.
That's actually the answer. This isn't a perfect square problem.
Okay.
But it's a factoring problem, but it's just a greatest common problem. All right. Let's see here. Let's try this. Did we do this one? No, I don't think we did.
No. Couldn't you pull out 3 from all those?
Okay. Does make it easier when you do that.
X minus 4x minus 5. And you got, and you have x, and the signs are going to be opposite.
Okay. So we want factors of 5 that subtract to the number 4.
It's 5 and 1.
The 5 goes
You're
away.
gonna put x plus 1, x minus 5.
Okay. You seem to have a pretty good handle on these. Is this factor?
Yeah.
Actually, no.
It doesn't?
The sum of perfect squares does not factor. The sum of perfect cubes does. Turns out that if I have x cubed plus 8, that does factor. This may be a step higher than you guys are doing.
Yeah, we haven't gotten there yet. That makes sense.
Well, it does. It is a little puzzling because there's a factoring for the difference of cubes also. So we have factoring for the sum of cubes and we have factoring for the difference of cubes, but we don't have factoring for the sum of squares. It turns out if it's even numbers, you don't factor, but if it's odd numbers, you do. In other words, we have factors for the sum of fifths also. But we don't have factors for x to the fourth plus 16.
Okay.
So if it's an even number, you can't factor the sum. If it's an odd number, you can factor the sum and the difference. What else do you need to go over?
That's all I can think
Have you
of.
had to complete the square?
No.
Okay, we won't go over that then. So you're factoring quadratic, factoring out greatest common factors, and you're factoring difference of perfect squares. And those are the three primary things we've done tonight.
Yeah. And then, the one other thing is we were making an equation from quadratic to vertex form.
Okay, let's do that. Give me the quadratic.
I don't have one handy, but I knew I didn't really understand that.
This is going to require completing the square.
Okay.
Make one up. Notice that doesn't factor very nicely.
No.
There are no factors of 5 that subtract to the number 1. So if I want to put this in vertex format is this. Right?
Yeah.
Okay. So the way I do that is I isolate that and then complete the square on that. I'm going to make this slightly easier. I'm going to put a 2 there. Just because it's going to be easier to understand.
Okay.
Haven't changed anything yet, right?
No.
Okay. So I'm going to complete the square inside my parentheses. The way I complete the square is I take half of this coefficient and I square it. And I add it right there.
Okay.
Since I added 1 to the right side of the equation, I have to subtract 1 to balance it. So I still haven't changed it. This equation that I've got down here is still the same as that. I didn't do anything. I just added 1 and I subtracted 1 to the same side. The The beauty is that now, when you complete the square, I can now write this as x plus 1 quantity squared. Combine those two numbers, minus 6. There you have vertex format.
Okay.
The vertex is where?
It's the minimum or the maximum of your parabola.
The vertex is h, comma k.
Okay.
What is h?
Isn't it your x value?
H is negative 1. And k is negative 6. In other words, if I'm reading h and k from that, I know that h is negative 1, k is negative 6. Notice that if I plug in negative 1 into here, I get x plus 1. That's how I get an h of negative 1.
Okay.
You with me?
Yeah.
So the vertex is negative 1, negative 6. Now, let's go over this with a slightly different scenario here. I'm going to put a 2 in front of that and a 4 in front of that. Makes it a little bit harder. Before I can complete the square, I have to make sure the coefficient of the x squared term is 1. So I'm going to factor out a 2.
Okay.
Haven't changed anything. Now I complete the square inside by taking half of this, which is 1, squaring it. But now when I add a 1 there, how many have I added to the right side of the equation?
1.
2.
2.
That 1 is being multiplied by this 2.
Okay.
So I have to balance it out by subtracting 2. So this now is 2 times x plus 1 quantity squared minus 7. Notice that's still in vertex format, just that's A. H is still minus 1. K is now minus 7. So the vertex is at minus 1, minus 7, but the equation has a 2 in front. In other words, the standard format is A times x minus h squared. In this case, that A would have been 2. But the key when you're completing a square and you factored out a number, make sure that whatever number you write in there, you multiply by that before you balance out the equation. And that's the only way I know to take it in standard format and convert it to vertex format, is by completing the square. So let me just give you another test on completing the square. Complete the square on this.
You start by pulling out 3.
Okay. Leave room for completing the square.
You take half of the middle term and square it, which would be
Just
1.
half of the middle coefficient.
Okay.
It doesn't matter if it's minus or plus because you're going to square it anyway. It's going to turn plus. So what am I going to write here?
Plus 1.
What am I going to write over here?
+1 again.
Minus,
no, +3.
Minus 3.
Minus 3.
In other words, you have to do the opposite if you're doing it on the same side of the equation.
Okay.
If I'm adding 3 to the right, I can add 3 to the left, balance. But if I'm doing both things to the right side of the equation, which I'm going to do here because I want a final number over here. So now I got 3 times what? How can I write that? It's always x minus, in other words, whatever half of that was, that's the number you want right there.
Okay.
Okay? Not this number over here, but half of this.
Okay.
And then that's squared plus 8. The whole point of completing the square is so that you can write it as x minus something squared, which is vertex 1.
Okay.
Okay. Anything else? We got a few minutes.
So on that one, your vertex would be -1, 8?
Yes.
Okay.
No. 1.
No?
1, 8. Remember the format. Always remember your general formula. The general formula is x minus 8 squared plus k. So in this case, h is +1. And k is +8.
Okay, so just normal one.
Yeah, in the other case, we had a +1, which made h -1.
Okay.
All right. Well, hopefully you'll be well prepared for your test. It feels to me like you are. I feel like you understand this stuff. You should do good on a factoring test.
Yeah, factoring's a little easier than some of the other stuff.
Yeah. Okay. Well, let's see. We're set to meet again tomorrow night at 8 for half an hour, right?
Yeah.
Is your mom probably is not aware that your session last night was free?
I don't know if she is or not.
Right, because she paid me for 4 sessions.
Okay.
She paid me for 2 hours, and so far she's only scheduled 2 hours. But the first half hour was free. So actually you still have a full hour coming without her needing to pay anymore, okay?
Okay.
So just let her know that, if you would.
I will.
And I will talk to you tomorrow night.
Okay.
All right, Silas. Bye-bye.
Bye.